My name is Michael Shara. I'm curator of astrophysics at the American Museum of Natural History in New York City. What that means is I do a combination of research at the museum in astrophysics, exploding stars, novae and supernovae, and I work with graduate students, postdoctoral fellows, in teaching them how to be the next generation of astrophysicists. I'm also lucky enough to be able to work on special exhibitions as part of my job at the museum. And one of those exhibitions was about Albert Einstein. In 1999, 2000, 2001, I assembled all of his writings, his papers, an original E=mc² that I was able to hold in my hand, and use those papers together with our wonderful exhibitions department to put together an exhibition that was seen by several million people over the next decade about Albert Einstein's life, his times, and his science and his physics. The question that I think I've enjoyed the most as part of the Q&A of the Einstein presentation, the Einstein exhibition, is what would Einstein be doing if he were still alive today, more than 50 years after his death? My answer varies, but I think that the correct answer is he'd still be working on a grand unified theory. Nobody has succeeded in unifying the physics of the very large gravitational theory with the physics of very small, what we call quantum mechanics or quantum theory today. And a unification of those two theories is essential if we're ever to really progress in physics to the next great steps in physics. Nobody understands many things that are deeply rooted in modern physics, and it's only with a unification that those things are going to become clear. And that, I think, is what Einstein would still be working on today. Typical day at work for me as a curator is a combination of research, time spent in front of a computer analyzing astronomical data taken by large telescopes, sometimes the Hubble Space Telescope or other telescopes, and talking and working with my graduate students and postdoctoral fellows. And so in that sense, my work is very much like that of a university professor. But instead of teaching courses, what I do instead is I do exhibitions. These may involve space shows for our planetarium, space shows on various topics, and occasionally exhibitions like Einstein, which are seen by large numbers of people who come to our museum and then to other museums where the exhibition will travel to. To become an astrophysicist, you have to be very comfortable with and fluent in mathematics and physics. And so from the time of high school onwards, you should study as much maths as you can. Mathematics is the language of science. That includes, of course, algebra and geometry, but also calculus, some statistics, a little bit of group theory, and certainly also computer science. You need to be able to program a computer, and that's not just an astrophysicist or a physicist, but any chemist or biologist or mathematician today should be able to program a computer, to be able to make a computer do what he or she wants, and that's really going to be a very essential part of your career if you're a scientist. There really isn't too much mathematics or science that you can study while you're an undergrad here. It's not just going to make you scientifically literate, which is important in today's world, and able to make better decisions, but if you want to have any kind of position in any kind of technology firm, whether starting your own or working for someone else, some other firm, the more you know about science and technology, the more able you'll be able to be to assimilate very technical data, technical information, understand complex problems, and solve them. The very best thing about what I do, about being an astrophysicist, is the fact that I essentially never do the same thing twice. I would get bored if I had to, and the reason I don't have to is because the universe is a vast place. I work on several different problems in astrophysics, both by myself and with my students and with my colleagues, and we're always tackling something new. And if occasionally we get lucky and we solve a problem and we publish the results, well, that's wonderful, but there's so many more challenging questions to go on to that I know I'm never going to be bored, and so I really look forward to getting up on Monday morning and going to work because it's fun.